says to graph 4 points and then in order and then to draw a polygon. So I'll just write down. It says to graph.
Too high.
Oh, bummer. But I need it. How's that?
Yep.
Okay, so it says to graph 4 points, and they gave you the names of the 4 points because it's easier on a graph to just put one letter than it is to put the coordinates there. And I need to label the points, so they make sense to me. So we usually label with letters. So it says to graph these 4 coordinate points and then find the perimeter of the, and then connect them and then find the perimeter of the polygon. So that's what I'm doing right now. I'm going to write these down.
So I can infer that if they're going to have me find the perimeter, it's going to be some sort of a closed polygon. That's an inference I can make.
That's a great thing, because if when you graph it, you don't have a closed shape, then it's a good point to double check.
Which means that it's going to be named polygon ABCD.
Correct. We name them by the letters that make up the vertices. These are, and it does say it in the problem that these are the vertices. Okay, many vertices, or there's one vertex, and I'll label that on the shape when we get it. All right, so I'm making my coordinate plane. I don't know why, but I always do Y first. I don't know. I'm trying to be straight with it. If I had a better ruler, I would put a ruler on, because that's actually, you know what, I'm going to. I'm not going to say if, I'm going to do it. I think I did a good job on them. Especially for graphing, it's going to be really important that you are using rulers. So let me go ahead and do that. Okay, we're going to put over here in our thinking bubble. First thing we always want to do is we want to make sure we are using a ruler, especially when you're graphing, because being precise, this is good. Mathematicians are thinking about these things. So you definitely want to have a ruler. All right. Could have gotten a longer one, but that's all right. We're going to make do with what we got here. Okay. I put the arrows on either end always on a coordinate plane, because it's showing me that those 2 lines are going on forever. They are lines and not line segments.
Infinite. They have an origin, but they do not have an end.
Okay, the origin is where they both start. It's where both lines intersect and come together. Intersect, or we call it the intersection. Okay.
These
all right.
Intersect perpendicularly, which means they meet at 90-degree angles.
That's a 90-degree angle. 90-degree angle is that sharp corner you find on boxes and corners. That's a very important shape. It's a very important geometric idea.
Piece of paper is the best way to, the corner of a piece of paper is the best way to check that one.
Absolutely, because you usually have a piece of paper around.
It's a tool, right? Or a Post-it.
So one of the things when I'm asked to graph and I'm setting up my coordinate plane, I want to look at the coordinates. And so what I first want to do, so if I'm going to look at the x coordinate alphabetically, I want to look at each x coordinate. And I see that they go, the range, remember we talked about range before, they go from 0 to 5. So a good scale for me to use is 1 for every unit. Now I only have to put 5 tick marks on here and I've got a big space. I'm going to space them out a little bit. It makes it a little bit easier for me. So 1, the important thing when I'm doing this is that the space for 1 unit is the same. So I like to use a finger, or if I didn't have a finger, if I didn't want to use my finger, I could do a ruler, or I'd fold a piece of paper to that size. Maybe that's what I'll do, is I'll take a Post-it note. I'll fold it right to the size that I want to use for 1 unit. Because the important thing right now is to be precise. I need to make it skosh bigger. Skosh, that's not a precise word. So now I'm going to space it out, and then this must be 2. This space must be 3. This one must be 4. And 5. You want to be a ruler and you want to be precise. You want to be neat with what you're doing. Okay, immediately once I do one side of the number line, I want to do the other side because I want to start thinking about labeling. Oh my God, here I'm trying to be precise and then I'm not. -2, that's why we work with pencil. Then I'm stepping away again, -3, and then I'm stepping again, -4, and I'm stepping again, -5. If I really want to use my graph to solve my equation, I need to be precise with it.
I might take a shortcut. And since I knew I only needed 5, I might not label 2, 3, and 4, but.
Definitely a possibility. And if I knew I was not going to use my graph, if I was more using my graph as a picture and not as something I was going to really read numbers off of, which is what I usually do, I usually just use it for a picture, I'd take a little bit short of a shortcut too and eyeball it as I'm ticking off. But I want to be able to check my work 2 ways, so this time I really want to be using both. Okay, I see that the y coordinates are 4, 4, -3. Again, the range is only going to be from 0 to 4, no more, or 0 to 3. So I'm going to use my same spacing. Why make another? 1, 2, 3. I didn't even need any more. So I'll label them 1, 2, 3. I like this part for me because I'm working, but I'm not really thinking too hard right now. And that's kind of a good thing. I'm kind of thinking about the problem a little bit. I'm feeling good about all the things I'm putting down on my paper, but I know I'm not.
And remember, the ones that are in the positive have a plus sign. It's invisible. It's one of those invisible things in math. You can't see a positive sign, but they are positive integers.
So if you don't put it there, it's assumed you meant to say positive. It's one of those things that's written so many times, we just assume it after a while. Okay. All right. Now I can start graphing those 4 points. And I have lots of pretty colors here, so I'm going to do each one in a different color. So A, the graph is 0, 4. So 0 tells me to start at the X. 0 tells me don't go anywhere. Stay right there. So I'm not moving away from the origin at all. I'm staying right there. And then I'm moving up 4 spaces, 1, 2, 3, 4. So this point right here, point A, is right on the number line. Right on, I'm sorry, the number line, yes, but right on the y-axis right there. I'm gonna do B in blue. B tells me to go to the origin and go over 5. 1, 2, 3, 4, 5. And then it tells me to go up 4. This is where my ruler comes in handy, because what I want to do is I want to draw my line. I'm going to make a straight vertical line. And then I'm going to come over here to 4, and I'm going to draw a straight horizontal line. No, I lost a little straight. And that's where I'm going to put B. And now, and I would erase it. I'd make it nice and light, or I would just have used my ruler, made a little mark there, okay? And that's how I get B, and that's how I get it in the right spot there. And that's at 504. C, and do that one in red. Okay. Do that one in red. C is at 5 and -3. So I go over 1, 2, 3, 4, 5, X first, and then -3 down to 3. So here's what I'll do is I'll draw this line down. I'll just draw it for a distance down. And it doesn't look too straight, so I'll be careful. And then come over to -3. And where those two come together, that's the coordinate. Just like when we were enlarging, you had those little crosshairs, that's what they're called. That's what we're making here. We're making our own crosshairs. And now we'll erase the part we don't need.
I hope you're taking notes. Remember, this is one of the problems you need to complete.
Okay. And there's C, and that leaves me with D. And I haven't used, let's see. Green. I haven't used green yet.
Or you're actually on the page, I guess.
Okay, is that okay? I can see everything okay?
So far, so good.
Okay. All right, I'm going to do D now. D says the x coordinate is 0 and the y coordinate is -3. So again, it's another one right on the axis, and that's D. Now, the next thing I want to do, it doesn't tell me to do that, but actually the problem, I think it does say to connect those lines. I'm going to do it in purple just because I wanted to stand out from my coordinate plane, which I chose to draw in black. I'm going to connect the lines. Again, use a ruler. Don't try and do it without a ruler. Now, my ruler isn't long enough, but I know it also went through 5, so that's going to help me. Do it there and here. And then the final line is going to be right across, right down the axes here.
So I can make some assumptions. If the x is 0, then it is on the y-axis.
Yes.
If the x is 0, it's on the y-axis. And if the points have the same, if the line segment has the same A or B point, then those lines are going to be parallel. So B is parallel to C because B is parallel to
These point, you need a line segments are parallel. A and B are parallel. The line segment AB is parallel to the line segment.
Yeah, and they're parallel because they have the same y coordinate. All right.
So I like what you're doing. That's why I started to put the coordinates in there. It's very important to stop and do what Mrs. Nelson's doing right now, starting to make inference, assimilating information a little bit, starting to think about what's going on.
Because once you understand all of this, then you can start taking shortcuts. You can start knowing things. You can assume, you can make assumptions that are based in fact.
So with that in mind, let's look at this point. Now the question asks you to find the perimeter.
And in order to find perimeter, I have to find distance. In order to find distance, I have to find absolute value.
The perimeter is the length of all the sides. So it's the length of side AB, line segment AB, and that's how we would write it, as a length segment at AB, and it's the line segment of BC, and the line segment of CD, we still write it alphabetically even though it would be DC or CD, and the line segment of AD. If I know the lengths of these line segments, then I can add them all up and get perimeter. And then what it is really asking me is, how far away is point A from point B? How far away is that distance? And that will tell me the line segment. So that's what Mrs. Nelson was talking about here. So if I look at point A and point B, we notice that their y coordinates are the same. So to go from A to B, it's the absolute value of the x coordinate plus the absolute value of the other x coordinate, the ones I didn't cross off, which is 5 spaces. And we know that from the number line. If I went from 0 to 5, I would move 5 spaces. So AB is 5 spaces.
Can I just go ahead and mark the bottom one now too?
I would.
Since I know they're parallel, right? I know how to do that process. So now I don't actually have to do it because I know it's parallel, right?
Correct.
Okay.
What you know, and I'm just double checking it. Yeah, they have 0 and 5 also, just like the other one. So I'm double checking it. So I can put that in, substitute what I know again, use a ruler. Again, the next thing you want to do is you want to write your formulas. And I love perimeter formula. I love perimeter because it's the same formula for all of them. Just add up all the sides. I don't care what kind of shape it is. We're just adding up all the sides. So I'm putting down the formula and I'm substituting what I know. Love that wherever you can, look for those patterns. I can infer then that A and D are the same as B and C. I can just, since I was so careful with my measurements, I can just count the distance of the spaces between A and D. 1, 2, 3, 4, 5, 6, 7 spaces. That's
Units, 7 units.
7 units, yes. Or I can do what we did with the other one, and if I look at A and D this time, 0 is a match, and I see that this is 4. So I see the coordinate for A is 4, so the absolute value of 4, and I see the coordinate of D is -3, the y coordinate, so the absolute value of 4 is 4, the absolute value of -3 is 3, and it's still 7, so I've checked it now 2 different ways.
I could do one side with measuring the distance and the other side with the absolute value.
Oh, that could have been done too, and then you double check it.
Yep.
We can do the same thing here. They have a match with the 5. So again, absolute value of 4 plus the absolute value of -3, and all together that is 7. And it matches there. So the perimeter, I just need to add those up. I have 2 5s, that's 10. I have 2 7s, that's 14. 10 and 14 is 24. 24 what? We don't know. 24 units then.
Now, can you do me a favor on this formula? Can you also show them how we could write that, right? 2, since we know it's a parallelogram, right? And with the perimeter, we could put 2 times one side plus 2 times the other side.
See, what happens is we know that this is a rectangle, right? We know it's a rectangle. And we know that AB and AD are the same. So I could have written it as 2 times AB. And then again, we see that BC and CD are the same, plus 2 times CD. Now I has to say this because this is telling me it's a line segment. Here's another thing I can do. Here's what mathematicians do when it's 2 times and it's parentheses. They just take that off. Again, it's one of those things that's invisible. It's implied. Now, when I have a number 2 right outside of parentheses, it means to multiply. So 2 times the length of AB and 2 times the length of CD, or 2 times 5 and 2 times 7 is still going to give me 24 units.
10 plus 14.
This is 10, this is 14, and it gives me 24 units.
And that
is how you do number 1. Now, should number 1 ask you for the area like number 2 does, the same thing. Use the ruler, be precise and neat, use your formula, except this time you're finding the area formula, you're substituting, and then you solve. These are the steps.
Type into the chat right now if you know the area of this figure and put A equals the area.
Do you know the area?
Type it into the
Rectangle,
chat.
that's 5 by 7.
In this particular problem, you needed to model and find the answer. You needed to model and find the answer. So you need to do both of those things. Sometimes you're only asked to do one or the other.
Sometimes you'll get the picture already drawn for you and they'll ask you questions. This time we actually needed to draw the picture. We needed to draw it right on that. We needed to draw that model right on there.
And when I ask you to answer that question just for me, you could just send that to Mrs. Nelson.
That way, just not everybody gets the answer and everybody's thinking a little bit, right?
Because what turns this into a junior high problem over a 3rd grade problem, right, is that the requirements get bigger and bigger. We've been finding area for a long time. Now we're actually putting that rectangle into the coordinate plane. We're actually labeling the vertexes. We're actually labeling the line segments. We're naming them. We're naming and labeling them. And we are writing formulas, because formulas are something we need to become familiar with as the shapes and change.
Definitely. And we're paying attention to the terminology. We're paying attention to terms like intersect. That's where the line AB intersects with the line CB. That's a vertex, that's a point. And paying attention to those things called perpendicular. This happens to be a rectangle. All of these angles happen to be perpendicular. This is the symbol they show. And by putting that symbol, it's assumed that we've said it's 90 degrees, which is the way you measure it if you had a protractor.
And that is the way you study and figure out the answers in math.